because it is going to delay me. But I feel that I cannot miss this question number 1, which is probably one of the most terrible inequality question that you will see coming out in exam. You look at the way that it is being set. This is an extraordinary inequality question because this is a 7 marks inequality question. 7 marks. Usually inequality question varies from, I've seen 3 marks question before, and usually the maximum I've seen is 5 marks. And this is 7 marks. And the worst is they didn't actually tell you the marks allocation. So now this question has made it even more difficult. I'm going to skip the first part of this question, which is supposed to be requiring us to solve it without using the graphing calculator. There's difficulty in the first part by itself, okay, but it's not as bad as the second part. So for the first part, let me just write down the answer first. First part, we are supposed to solve this inequality. This, then 5 minus x squared. This is less than or equal to 4. If you were to work out this inequality, you're going to get the answers as x to be equal to minus 3 over 2, or x is supposed to be less than square root of 5, or x is supposed to be bigger than square root of 5. So this was from the first part, and the question says, hence, solve another inequality. The second inequality that you are supposed to solve is this. Is this x, then 12 plus 29x. This is going to be divided by 5x squared minus 1. This is less than or equal to 4. So according to what we have discussed in June, and together with some of you, we have talked about this since last year, that when a question asks you to solve an inequality question that is as complicated as this, but not using the graphing calculator, they have another intention. The intention is not about you solving the inequality. It is something else. It should be very obvious to most people, but a lot of people, they just didn't see this. And we are looking at a bell curve, which means that if we can see, but the cohort didn't manage to see this, a question that is like this is not focusing on inequality. If we are able to recognize this, then we have an advantage on the bell curve, because most people will try to practice this kind of question as if it is inequality. But we are not going to. We have another focus. Because if this question were to be a pure inequality question, they would have asked us to solve this using a graph. Because the graph is a better way to solve this inequality than to intentionally make this question to be solved without using the graph. So what is our focus? What is the thing that we are trying to practice for? It is our logical analysis and algebraic comparison. It is the aim of doing a question that is like this is to up our sensitivity to logical analysis, is to up our sensitivity to algebraic comparison. And that, if I were to miss it, then I would have done this whole question as if it is I would have done an inequality question as if it is very, very easy, but it is really not. And we want to discover this once again by looking at the hence part of this question. We are going to be using our logical analysis. We are going to be using our algebraic comparison, okay, for this, which is not the best tool. Let us remember, this is not the best tool to solve this inequality, because by working on algebraic comparison and logical analysis, it makes this question way, way harder, and AJC is not letting us go by setting this hence. First of all, I actually still think that some of you are not using the strategy that we talk about for this particular kind of question. The first part, we are supposed to solve this. The second part, hence, we are supposed to solve this. So with your exam experience, you can already predict what kind of question this is, right? It is to replace x here by some expression to get this. Replace x by something. So all this x, I'm expecting it to be replaced by something in order for me to solve this. Replace x by something. And we had a strategy. A strategy that can help us to do this kind of question, a strategy that can help us to do the complex number polynomial kind of question, where they ask you to solve a polynomial with complex roots, hence solve another polynomial. So you'll be expecting, after you have gotten the first set of roots, the z is going to be replaced by something. Let me just very quickly show you the solution. This particular set of solution is very good for learning because it doesn't explain to you a lot of things. So that's what I want to try to go through with you now, okay? So that is what I'm very tempted to do. That's why, although 6 was my primary focus, but I'm going to just okay, I don't think I can even do it fast, okay? But I'm going to just take up a bit of your time to look at this. So, first of all, they already give us a hint. X is going to be replaced by 1 over x. This is bad. If you were to just receive the fact that, hey, x is going to be replaced by 1 over x, oh, I understand, because I can just try to replace all this x here by 1 over x. I do a bit of manipulation. I realize that algebraically it is the same as this. Then I thought, I know that x is going to be replaced by 1 over x. But like what I was trying to share with Surendra just now, we need to ask ourselves, why? How do I know if I'm not given that x is going to be replaced by 1 over x? How can I increase the chance of me still being able to see this during the exam? X is going to be replaced by 1 over x. So what was our strategy? And in case you have forgotten or you just don't use this strategy, my sincere recommendation to you, right, is to really consider memorizing this strategy. The default process is definitely to try to use your observation to see what x is going to be replaced with. That is the default. But what if you cannot observe what x is going to be replaced with? Like for example, this case. It's very difficult, at least not for me. I cannot see what x is going to be replaced with. And the moment when you find that you don't know what x is going to be replaced with, you shift your focus. No one will actually do this, but we have discussed about this. It's a very good strategy. We will shift our focus. We will shift our focus to the term that is independent of x, which means that I'm going to shift my focus to 29. I'm going to shift my focus to 5. I'm going to shift my focus to 4. Because I know how this kind of question is set. X is going to be replaced by something, which means if x is going to be replaced by something, 29, 5, 4, they will never be replaced. Instead of working on what x is going to be replaced with, I'm going to shift my focus to work on what x will not be replacing it with. So for example, if I were to look at this again, I'm not going to take care about x yet, since I cannot tell what x is going to be replaced with. So I'm going to work with 29. It is an independent term. So now it is not an independent term, it is still involving x. I'm going to factorize out x, which gives me x squared. Then this I will have a 12 over x plus 29. And now I have a term that is independent of x, that is 29. In the denominator, it is not 5. It is 5x squared. So I am going to factorize out x squared so that I can have an independent 5. And this will become minus 1 over x squared. This is less than or equal to 4. X squared can be cancelled. And now I have it. It is 12 times of 1 over x plus 29 divided by 5 minus 1 over x squared. This is less than or equal to 4. This is how I can increase my chance of more consistently knowing how x is going to be replaced by whatever expression. It can be applied for all of this kind of question, and like what I was saying, also for the complex number polynomial kind of question. But this is not my discussion with you. This is just a recap of what we have discussed. I want to experience this. I want to practice this with you because that should be our focus when we are trying to do an inequality question that allow us to use the calculator less. So it is from here, I'm going to replace all the x by 1 over x, which means that I will be getting a 1 over x is equal to minus 3 over 2, or 1 over x is going to be less than minus square root of 5, or 1 over x is going to be bigger than square root of 5. I now have 3 cases. I think this is brainless, so I don't have much problem for this. This is minus 2 over 3. So let's look at this and this. What if someone do this? Okay, I'm going to multiply this over. Then I get x to be bigger than, x to be less than square root of 5. Or I can also rewrite this as x is less than square root of 5. I mean, these are the same. Okay, it's just, I'm just switching this over. So I can cross multiply and get this. I mean, we know something, right? Okay, why not we try to simulate how a student will be going through this question. It is the very first question in pure math. Sorry, it is the very first question in paper 1. And part 1 by itself, there were already going to be some algebraic comparison and logical analysis. And you're not supposed to be using the calculator, which means that you'll be going through that process that the school has taught you, which is a very good process. We went deeper into that process to see what are happening in the background because we want to up our ability to do that logical analysis. So we have done a lot of algebra here. And then suddenly, here we also need to do quite a lot of observation and algebra in order for me to know that x is going to be replaced by 1 over x. And there will be probably some people, when they are looking at this, then they just get a little bit more relaxed. Then they will just cross multiply. But we know that this shouldn't happen. Although I believe, even for myself, right, when I see something as simple as this, I wouldn't think that this is as complicated as this, then I cannot cross multiply and stuff. So accidentally, we may cross multiply. We cannot cross multiply unless we know that the expression that we are cross multiplying is always positive or always negative, right? So this is actually not correct. But if you were to look at the answers, you will realize that, hey, from here to here, x is indeed less than 1 over square root of 5. Which means that by cross multiplying for a case that is like this, going from here to here, when I cross multiply, we actually get it correct. And this is very, very dangerous. You know why? Because we have discussed about it before. When I do my practice, I would rather get it wrong than to accidentally get it correct. When I accidentally get it correct, that means somewhere down the road, we are going to definitely get it wrong. And I don't want it to happen in our A-levels. That is why this is very dangerous. Because going from here to here, we are accidentally getting it correct. How can I prevent myself from accidentally getting it correct? Because this is not fully correct, of course. The fully correct version, according to what AJC has written here, is x is supposed to be bigger than 0, less than 1 over square root of 5 at the same time. So how can we make sure that it is not just this? How can we make sure that it is still going to be bigger than 0? We can use existing strategies, like for example, one that the school has taught us. If I were to use existing strategy, this is what I'll do. I'm not going to relax when it comes to inequality. So if I were to use existing strategy, this will require me to bring everything to one side so that one side is equal to 0. And whatever that is on the other side, I'm going to try to make it into one single expression and making sure that it is going to be multiples of linear expression, for example, like this. Once it happens, I can then draw my number line. It is going to be 0 here. It's going to be 1 over square root of 5 here. If I were to sum in numbers, I have a minus, plus, minus. I'm looking for bigger than 0. So x is then going to be between 0 and 1 over square root of 5. That means if I want to process this and I have a good structure to follow, of course, I'm going to follow this structure. Another way to make sure that I get this totally correct is to try to sketch a graph. But I do think that if I were to follow the structure, it's actually pretty fast. Okay, so although sketching a graph is also quite fast, but I think most of you probably will prefer using this than to sketch a graph. But of course, when you are redoing this question, if you plan to do that, you can consider drawing a graph and see how it works. But let me tell you something about AJC's solution. AJC set the hardest paper, but AJC also produced the shortest possible solution. They are very consistent. Very difficult paper, but very short solution. From here to here, this 1 over x bigger than square root of 5 to this x is between 0 and 1 over square root of 5. You may think that AJC skipped steps. So they skip this step, or they skip the graph, and they derive at this solution. They didn't skip step. Let me tell you, they didn't skip step. What they didn't manage to write down was only because it is in the thinking, it is in the reasoning, that they went from here to here. Their reasoning is hard to write down. It's hard to pen down. That is why probably, they didn't write down, but they thought about it. Can you try together with me now? Or can you guys try and give me your reason? Why do you think this is this? Just by logical reasoning. Can you see why this is this? Let's try to practice our logical analysis and algebraic comparison. Anyone can give me your opinion? Why is it that you can just by reasoning say that this is this? Can you think about it? You can use logical reasoning. Especially the bigger than 0. Because if I were to cross multiply, I will miss out this bigger than 0. So somehow this 0 sort of like appear. Why is it that I can actually go from here to here just by reasoning? This kind of reasoning is good because that is the focus of this particular inequality question. By using an inequality as a media to help us to increase our ability to do logical analysis. If you think about it, let's think, okay, I don't need H2 math to do this, which means that you already possess this skill before you even start your JC. It's just that you need to find a way to trigger this. And the way to trigger this is not trying to teach you about inequality, it's trying to give you a problem. That is what your H2 math is trying to do to you, you know. It's trying to bring out your potential. If you don't let H2 math do that, you will miss the chance. If you were to look at this, this is a number that is bigger than square root of 5, which is a positive number. What does it tell you about this number straight away? It is a positive number. This has to be a positive number because it is a number that is bigger than square root of 5. If this is a positive number, it means that x must be positive, right? Which means that I'm dealing with a positive number where x is positive, and since x is positive, can I cross multiply? I can. So I can cross multiply and there's no problem. But when I cross multiply, I'm only saying that x is smaller than 1 over square root of 5, which is unreasonable because x cannot be just smaller than 1 over square root of 5 all the way. In order for me to see this, I know x has to be bigger than 0. So I I put in my reasoning. So x is supposed to be bigger than 0. And you must understand that this is very difficult to do in an exam. You don't want to do this in an exam. You want to continue to practice this in case some questions force you to do something that is like this. But I need to see that doing it this way is challenging. You shouldn't try to make this your default process in an exam. Unless the question forces you. The question can very easily force you. Like for example, part 1 of this, without using a calculator, solve this inequality. They can force you. So you need that muscle, but you don't want to anyhow dispense that because you know how much you need to reserve in order for you to plow through an AJC paper. We can apply this, okay, now that we see this, we can apply this very easily to this. If you were to look at this, AJC again went directly. Okay, let's try to use the same idea to see how we can get this directly to this. Now I have a number that is less than negative square root of 5, which means that this number is negative, which means that x is negative in this one. So since x is negative, I can cross multiply since I know it is negative. So when I cross multiply, the inequality sign will change because x is seen as a negative number. Then I'm going to divide this across to the other side, which is a negative number. So the inequality sign will change again. So I have this. And since I'm working on an x that I already know is negative, it cannot be possibly just bigger than negative 1 over square root of 5 all the way. So I need to add in a less than 0. I'm working with a negative x. Despite us trying to do all the possible things that we can do to do our analysis, we will realize that this is still not going to get us the full marks. That's the problem with this question. Even after I've done all this, if you were to look at AJC's solution, we have missed out something. We have missed out the fact that 0 is a solution. That's what AJC said. 0 is a solution, which means that somehow, okay, you need to know that, hey, it can be equal to 0, it can be equal to 0. So when I merge this solution together, my final solution is x is equal to minus 2 over 3, or x is going to be between negative 1 over square root of 5 and 1 over square root of 5. 0 is included. Two things that I want to highlight to you about this 0. This is very, very important. First of all, you will realize that even when we are trying to stick to the school's process, so that we can generate this plus minus, this process is actually a very algebraic analysis process. It's just that it works so well that we can almost follow a template. We will not allow you to just follow the template, or else you will not be learning much of or else you will be just we will just miss the point, okay, of why are we trying to solve inequality using a more difficult method. I must well use a graph. So you'll realize that they do start testing us on moments when we are supposed to use our own analysis. For example, like this question, if you do go through the template, you are still supposed to be recognizing that, hey, x cannot be equal to plus or minus square root of 5, for example. Because if so, then it is going to cause the denominator to be equal to 0. So we need to recognize this, and to recognize this is our logical analysis. It is not part of that structure. And remember, I was telling you, how do you find numbers that is excluded or included in your final solution? You never go for anything that is in between. You must always go for the very original inequality. You must always go back to the original question and ask yourself, are there numbers that I'm supposed to exclude? Are there numbers that I'm supposed to include? Because if you were to look at this, If you go and look at in between, if you go and look at 1 over x, can x be equal to 0? It will not be equal to 0. X cannot be equal to 0. So if you were to look at anything that is in between, you cannot find those numbers that can be included or excluded out of all your reasoning, to get your final answer. You must always go to the very beginning. In the very beginning here, can you see if x is equal to 0, then and the entire left-hand side becomes 0. So 0 is less than or equal to 4. Okay, 3. 3 is asking me, then isn't, 3 just asked me. Okay, 3 just asked me, but if x is equal to 0, isn't 1 over x undefined? Okay, so 3 had that problem because she went to look at the in-between. You cannot look at the in-between because the in-between is your own manipulation. It is not what the question intended for you to analyze, which is this. So you must always trace back to the original one. X can be equal to 0. Okay? This is my first point about this 0. The second point is, how do you even repeat? How do you even find this 0, How do you even know that this 0 is going to be part of my consideration? Let me show you the best way to get you to understand about this 0. The best way to get us understand about finding this 0 in my process here. Okay, because the most difficult thing is not even all this that I've discussed, it is how can I find this 0 if I don't even know that 0 is of my consideration. Very few people, including myself, will still, after I've gotten this, after I've gone through this whole thing, I really feel that I'm doing a 7 marks solution for the question already. So I will not go and just search, so that I can search this 0. Let me show you something, okay? What if I were to solve this using a graph? What if I were to solve this using a graph? Let me show you the graph. I've already sketched it myself. You don't have to sketch this. Let me just very quickly do a sketch. I can draw the graph in 2 ways. I can draw the graph of the left-hand side, y1, and I can draw y2 as 4, then I can solve the inequality. But personally, I like to draw lesser graphs, because the more the graphs, the more complicated it visually will appear on my graphing calculator, so I'll increase my careless mistakes. So to reduce careless mistakes in the exam, I'll rather try to bring everything over to one side. This is my preference. I'll rather bring everything over to one side as long as it is convenient. Then I sketch the graph of y is equal to x, 12 plus 29x divided by 5x squared minus 1 minus 4. You do need to do some analysis to this in order for you to know its features, but I've already done that. It will have 2 vertical asymptote. I think this is obvious. X is equal to minus 1 over square root of 5, and x is equal to 1 over square root of 5. You will have a horizontal asymptote. You do a long division to this, then minus 4. You're going to get a horizontal asymptote. The horizontal asymptote is y is equal to 1.8. And from the calculator, you're going to see this. From the calculator, you're going to see this. From the calculator, you're going to see this. Touch. And then you will tend to the vertical asymptote. It touches here at minus 3 over 2. Minus 2 over 3. It touches here at minus 2 over 3. This is when y, this entire thing is y, is equal to 0. So it satisfies the inequality. So equal to 0, this is 1 point. So I know this is included in my solution. And I'm looking for the values of x such that y, or the y coordinates, are less than or equal to 0. So this part also satisfies the inequality, right? The y coordinates are less than 0. So it is going to be between, you cannot take out these two values, so it's going to be between this and this. So you'll be between minus 1 over square root of 5 and 1 over square root of 5. Do I even have this problem about recognizing 0? Do you realize how quick and easy this is? I don't have this kind of problem. This is a big problem when I'm trying to do this myself, algebraically, by using reasoning, by using logical analysis, by using algebraic comparison. I'm doing this myself without using the best tool. That means I'm using the lousiest tool to try to solve an inequality question. I'm using the wrong tool. And your school purposely is trying to ask you to use the wrong tool That's why we must recognize this question is not just focusing on inequality. This question is focusing on our ability to do analysis. Can we draw the graph for using this question? We can't, because the question says hence. If the question didn't say hence, if I had done this, I would have gotten it super fast and very, very accurately. Why? Because graph is the best tool. It's the best tool. It's the premium tool that you can use to solve questions where the domain is a continuous set of values. The domain is a continuous set of values. The domain has a lot of numbers. The domain has a lot of numbers. I'm expecting this, when I solve it, to have a lot of numbers. The more when you are dealing with a question, when you are expecting that the solution, or you are expecting that it is going to be dealing with a lot of numbers, for example, like this case, you have to choose the right tool. If you choose to do numerical substitution, if you choose to use algebraic analysis, you're going to bump into a problem that is like this. And the point that I'm trying to make is I cannot solve this zero problem. There's no way that I can help you to solve this zero problem. You know why? Because we are using the wrong tool. You know, that day a student was asking me, after we have done this question, so how do we know that x is equal to 0? I can't answer that. I really can't answer that, because you are forcing me to use the wrong tool. You are forcing me to use a cross screw to go and like unscrew what is that? The wrong kind of nut. Wrong. I can't. Graph is the best possible tool. So this zero problem cannot be solved using algebraic analysis, but we can definitely play some exam smartness here. In an A level, you have time to check your inequality. Prelim, I don't think so. So this zero, I'll probably have to let go if it really appears in a prelim. But A level is different. A level, you can actually plan well enough so that you have enough time to check. If there were to be an inequality question, or if you have a question that could have been solved by graph, but the question asks you to do it algebraically, what you can consider doing is, after you have finished the whole question algebraically, if you manage to plan well, draw the graph. But the moment you draw a graph, you realize that, hey, if this is my solution and not this, then there must be something wrong, because they are contradicting each other. My graph says that it includes 0. My solution here didn't say that it includes 0. So looking at the graph, it helps me to point to 0. That's the difference. Then I go and do my algebraic analysis again. Will 0 work? Because the graph shows that 0 will work. Then you will recognize the 0. But of course, you don't display this in your solution. And that is why of this entire solution here, although everything is by logical reasoning, I really doubt this 0 is true logical reasoning. There's no way that I can think of. I mean, unless you manage to focus back on this. Okay? Or else there's no way for you to very easily recognize this 0. This brings me to question number 6, function.